Okay, so hello and welcome back. So in this video we will continue with the exercise number 17. And exercise number 17 is the tan inverse of tan of 3 pi by 4. Tan of 3 pi by 4. And now in order to decide what is the tan inverse of tan of 3 pi by 4, we know that basically this is question number 17. So we know that the tan inverse of tan of x is equal to x if x belongs to the interval, which is basically the limited domain of the tan function, which is, I suppose, negative pi by 2 to pi by 2. So if I go to the tan inverse function, negative pi by 2 to pi by 2, right? So negative pi by 2 to pi by 2. And so now 3 pi by 4 is some angle which is 3 times 45 degrees, which is outside of this range. Which means that we need to somehow bring the angle to basically to this range, which is negative pi by 2 to pi by 2. Now the way that we can do that, we need to use one of the formulas that we had before. And about those formulas, so we need to basically do a couple of things. I have actually gone through those formulas, and what I mean by that is basically, first of all, these formulas, and we had a couple more formulas that we added to that. So we had pi by 2 plus x, pi by 2 minus x, pi minus x, pi plus x, and 2 pi minus x. We need to basically find some sort of rule in order that we can use these formulas properly and effectively. And the way that you can do that is basically, you see over here you have basically all the different trigonometric ratios of pi by 2, and over here you have all the different trigonometric ratios of pi by 2. Now this is pi by 2 minus x, and this is pi by 2. Over here you have pi by 2 plus x. Okay, so pi by 2 minus x and pi by 2 plus x, and you can see that basically when you have basically sine of pi by 2 or cos of pi by 2 and so on and so forth, when the angle over here is pi by 2, basically the trigonometric ratio changes in all of these cases, meaning that sine becomes cos, cos becomes sine, tan becomes cot, cot becomes tan, secant becomes cosecant, cosecant becomes secant. And the exact same thing happens here, sine cos, cos sine, of course ignoring the sine for now, tan cot, cot tan, and so on and so forth. So I'm going to basically create a couple of cases here, meaning that I'm going to create this case here, which is, I'm going to draw a simple table. And in this table, what I'm going to say is that I'm going to define some case 1, for example, in which case I have basically pi by 2 I have pi by 2 minus x, and I have pi by 2 plus x. I'm going to call that case number 1. Then case number 2, I have pi minus x, and I have pi plus x. So pi minus x and pi plus x, I have pi over here and pi over here. Actually pi minus x and pi plus x. So that I'm going to call case 2, meaning that pi minus x and pi plus x, I'm going to call that case number 2. And case number 3, I have pi by 2. I have 2 pi over, I have 2 pi minus x. I'm going to call that case number 3. Okay. So this is case number 1. This I have called case number 1. And this I will call case number 2. And I have also case number 3. So, there are two things that happen with these trigonometric ratios. First of all, in some cases, you have basically the trigonometric ratio changes, meaning that sine becomes cos, cos becomes sine, and so on and so forth. So we have the trigonometric ratio TR change, and we have also again TR change here, and we have also TR change here. And one more thing that happens is that in some of these cases, as you can see, the sign changes. In some cases the sign does not change, meaning that, for example, in the case of pi by 2, you can see that in none of these cases the sign has changed, all positive. In some of these cases the sign has changed, the sign hasn't changed in case of, for example, sine and, for example, cosecant, right? And in this case, pi, for example, in the case of sine and cosecant, again, hasn't changed. Over here, in the case of tan and cot, it hasn't changed. In the case of cos and secant, it hasn't changed. So there is also, I'm going to take the cases where the sign has not changed, right? So for example, in this case over here, in the case of sine and cosecant, the sign has not changed. It's positive, 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 right? So I'm going to call the other row or column or whatever you want to call it, not sign change. Not sign change. And again, not sign change. And again, not sign change. So I have this table over here, and again, to understand what is case 1, 2, and 3, I'm going to write here pi by 2 minus x, pi by 2 minus x, and pi by 2 plus x. I'm going to write here pi minus x and pi plus x, and I'm going to write here 2 pi minus x, and over here I have nothing. So I have under 1, I have 2 cases, and 2 cases, right? So I'm going to keep these numbers because I think we are going to need them. Now, what happens is that what happens is that basically you can see, basically you know that whenever you have pi by 2, the trigonometric ratio changes in the case of pi by 2 minus x, and also in the case of pi by 2 plus x. So I have two positive signs over here, meaning that in this case the trigonometric ratio changes, and also in this case the trigonometric ratio changes. Now if you take a look at basically pi, you can see that the trigonometric ratio does not change here, and also here basically the trigonometric ratio does not change, right? Which means that I have a negative here and a negative here, meaning that in none of these cases the trigonometric ratio changes. And in the case of 2 pi, you can see that the trigonometric ratio does not change. So that means that I have a negative sign for this, and since here I have a nothing, I put an x over here, meaning that it is just a placeholder for this. For this case that does not exist. Well, you could of course create that if you need to, but we don't have it in this table or in the tables that we have created. Now the sign change basically, you can see that in the case of pi by 2 minus x, which is this first case over here, the sign does not, the sign, actually that is not sign change, okay? So not sign change happens in the case of all of these basically formulas. So the sign, not sign change happens in the case of, I call it all for A for all. Now when it comes to pi by 2 plus x, then you can see that the not sign change happens in the case of sine and cosecant. And since cosecant is the inverse of sine, if I write sine, then I automatically know that the not sign change happens in the case of cosecant as well. So I simply write sine over here, S for sine. Now again, the not sign change in the case of basically pi minus x, you can see that it happens in the case of sine and cosecant. So you have again an s over here, pi minus x. You have again an s over here. And then in the case of pi plus x, you can see that the not sign change happens in the case of tan and cot. So I write tan, and I automatically know that cot is also there because cot is the reciprocal of tan. So I write tan over here, t for tan. And then there is also 2 pi minus x. There is 2 pi minus x. In the case of 2 pi minus x, the not sign change happens in the case of cos and secant. Secant is the reciprocal of cos, so I simply write cos here. I simply write cos here, and I have a placeholder here. And that is the table that we have for all of these trigonometric ratio tables that we have created so far. Now I can create basically a screenshot here and call it, for example, trigonometric identities rule, for example. Rules, and put it on desktop, for example. And that way we know basically what we are talking about. Okay. So now that I know, of course, you could work with this table and all of the other tables until you are fluent in them, of course. But now going back to the problem that we had, so we know that basically, so we wanted to calculate the tan inverse of tan of 3 pi by 4. The tan inverse of tan of 3 pi by 4, we said that basically the tan inverse of tan of x is equal to x if x belongs to negative pi by 2 pi by 2, and it's not the case right now. 3 pi by 4 is outside of this range. Now in order to bring this back to, so I can write the tan of basically the tan of 3 pi by 4, I can write it as, so I can basically choose either, I can choose either pi, for example. So this is 3 pi by 4, meaning that 3 pi by 4 is some angle over here. This is 3 pi by 4 is some angle over here. If I choose pi minus some angle, for example, it's going to give me some angle in the first quadrant. I think we can do that. And if I choose pi minus x, right, pi minus x, and if I write the tan of basically pi minus x is equal to, now since I have pi over here, tan doesn't change, it remains tan. And we said that basically, and over here you will get an x about the sign. This is basically so you had basically pi by 2, pi, and 2 pi. So this is the third case. And the mnemonic that we need to basically, the mnemonic that we need to learn here is basically ASSTCX, right? ASSTCX. So I have ASSTCX. Now this case, in these cases, this case is basically this case over here, which means that in the case of sine and cosecant, the sign does not change. In all the other cases, the sign will change, which means that I have, since this is no sine function, so this will change, and therefore the tan of pi minus x is equal to negative tan x. And then you can see the same thing over here. The tan of basically the tan of pi minus x is equal to negative tan x. So that's how you can use the table. And so what that means is that, and one more thing about the table is that you can see that the trigonometric ratio change happens only in the case of pi by 2. So both in the case of pi by 2 minus x and pi by 2 plus x, the trigonometric ratio has changed. In the case of pi, it doesn't change. In the case of 2 pi, it doesn't change. So I suppose the only thing that you need to learn is that the only case in basically in the case of which the trigonometric ratio changes is pi by 2, right? And then the second thing that you need that you need to learn is that basically the odd sign change is ASSTCX. ASSTCX. So now let's see if we can use this one over here. So tan of pi minus x is equal to negative tan x. Which means that basically you can write this as tan x is equal to negative tan of pi minus x, right? So that way you can write it as well. Let's see if we can actually use it. I suppose I did this once and I got into some sort of problem. But basically, if I say that basically so tan of 3 pi by 4, so I'm going to write this as tan of tan x is equal to negative tan pi minus x, right? And tan of 3 pi by 4 is equal to negative tan of pi minus 3 pi by 4. And what is pi minus 3 pi by 4? Pi minus 3 pi by 4 is equal to 4 pi minus 3 pi, which is equal to pi by 4. So that is equal to negative tan of pi by 4. So tan of 3 pi by 4 is equal to negative tan of pi by 4. So that means that negative tan of pi by 4. That means that I can write over here, instead of tan inverse of tan of 3 pi by 4, I can write tan inverse of negative tan of pi by 4. And I know that basically negative, or basically to be more exact, I know that let me actually, I need to get what we had over here. And then and so basically I know that tan inverse of negative x is equal to negative tan inverse of x for all x belonging to R. So I know that the tan inverse of negative x is equal to negative tan inverse of x for all x belonging to R, which means that I can write this as the tan inverse of, that is the tan inverse of negative x, so I write it as negative tan inverse of tan of pi by 4. And now, since pi by 4 is within this range, so I have no problem, and I can actually write this as negative pi by 4, which is equal to negative pi by 4, which means that the tan inverse of tan of 3 pi by 4 is equal to negative pi by 4. And that happens to be the right answer. Now the next question, I did try to solve it, but I couldn't solve it actually, and I couldn't understand the logic that they have used in the solutions. Now let's work through this example together and see if we can figure out the logic that they have used. If we can understand it, then we will use it. Otherwise, we will not solve the problem, because what you don't understand, of course, you cannot use. Okay, so there is basically two formulas here that have been used that we haven't proved or we haven't proved them, or we haven't had them before. And one of them is basically the sine inverse of A by B. Sine inverse of A by B is equal to tan inverse of A divided by the square root of B squared minus A squared. That I do not know how they have gotten here, but we have to use it for this exercise, although I have no idea where they have gotten this formula or how they have derived it. I don't really know. I tried to get the same formula, for example, using the formula that we had before. We had basically 2 times tan inverse of x is equal to, for example, sine inverse of basically 2x over 1 plus x squared for the absolute value of x less than or equal to 1. We had this before, and I tried to somehow get this but there is 2 problems here. First of all, there is a 2 over here, which could be not a problem. Actually, it would be a problem, meaning that you would have to somehow get rid of this 2. And we have, using the formulas that we know so far, we have no way of taking this 2 inside. For example, I do not know what is, if you told me, for example, if you told me, I know that the tan inverse of, negative x is equal to negative tan inverse of x for all x's belonging to R. So that is tan inverse of negative x. Meaning that if I had negative 1 times tan inverse of x, I could basically take this inside and somehow put it together with the ratio, and then write the ratio as basically negative x, or negative 1 times x, which is ultimately negative x. So that we can do. But when you have a 2, I do not really know what to do with that, right? So what I'm going to do is that I'm going to just simply use this formula as it is, and I'm not going to worry about that, worry about the rest. But another thing which is actually pretty interesting here is that they have written that basically the question is that you want to find the tan of the sine inverse of 3/5 plus the cot inverse of 3/2. Okay. So you want to find the tan of this angle, and basically using this formula, you can write this part as the tan inverse of something. And then if you write this part also as the tan inverse of something, then you can use the formula, for example, tan inverse of x plus the tan inverse of y is equal to the tan inverse of x plus y over 1 minus x times y for x times y less than 1. So I could put the two tan inverses together to write it as a single tan inverse, and then tan of tan inverse would be just the ratio, right? So now one interesting thing that they have written here is that the cot inverse of a divided by b, the cot inverse of a divided by b is the same thing as the tan inverse of not a divided by b but b divided by a, meaning the reciprocal of the ratio, which is interesting because as you can see, for example, let's go for pi by 6 radians or 30 degrees. You know that the sine of pi by 6 is equal to 1 by 2. You know that the cos of pi by 6 is equal to square root of 3 by 2. You know that basically the tan of pi by 6 is equal to 1 over square root of 3, right? 1 over square root of 3. You know that the cosecant of pi by 6 is 1 over sine of pi by 6, which is equal to 2. You know that the secant of pi by 6 is the same thing as the cos of 1 over cos of pi by 6, which is 2 over square root of 3. And you know that the cot of pi by 6, is equal to the reciprocal of tan, which is equal to square root of 3, right? So now I can say that based on this, I can say that basically, for example, based on this formula or this equation, I can say that pi by 6 is the same thing as the sine inverse of the sine inverse of 1/2. The sine inverse of 1/2. And also I can say that the same angle pi by 6 is also the cosecant inverse of 2, right? So you can see that the sine inverse of 1/2 is equal to the cosecant inverse of 2 by 1. The sine inverse of 1/2 is the same thing as the cosecant inverse of 2 by 1. 1 by 2, 2 by 1. Also, based on this formula, I can say that basically again pi by 6 is the same thing as cos inverse of the square root of 3 by 2. And also pi by 6 is the secant inverse is equal to the secant inverse of 2 by square root of 3. By square root of 3. So that means that basically the cos inverse of square root of 3 by 2 is the same thing as secant inverse of 2 over square root of 3. And you know that basically you know that, well, I'm not talking primarily about cos inverse and secant inverse, but you know that cos and secant are inverses of one another. Also sine and cosecant are inverses of one another, although here we have sine inverse and cosecant inverse and cos inverse and secant inverse and so on and so forth. So, and also based on this equation, I can say that basically the pi by 6 is the tan inverse of 1 over square root of 3, and pi by 6 is equal to the cot inverse of square root of 3, which means that basically the tan inverse of 1 over square root of 3 is the same thing as the cot inverse of square root of 3 by 1, right? And you can see that of course you know that tan and cot are the inverses of one another. So you can see that, so therefore based on this one over here, you can say that the sine inverse of A by B, is the same thing as the cosecant inverse of B by A. And also you can say that the cos inverse of A by B is equal to the secant inverse of B by A. And also you can say that the tan inverse of A by B is equal to the cot inverse of B by A, right? So these three formulas are well, I will write them somewhere down, and then I will add them to the formulas, okay? Now the problem that we wanted to solve was basically this one over here, which was basically number 18, the sine inverse of 3/5. The sine inverse of 3/5 plus the cos inverse of, plus the cot inverse of, actually the tan of all of this, the cot inverse of 3/2, and you want to calculate the tan of this angle, okay? Okay, so now to solve this problem, basically what we can do is that we said that the sine inverse of A by B, we said that the sine inverse of A by B is the same thing as tan inverse of A over square root of B squared minus A squared. Okay, so that is one formula that we can use for here. And also the cot inverse of A by B, as we argued before, the cot inverse of A by B is the same thing as the tan inverse of B by A. Okay, B by A. So now I can write this as the tan of the sine inverse of 3/5. The sine inverse of 3/5, I can write it as well, let's here the sine inverse of 3/5. I can write it as the tan inverse of basically A, which in this case is 3, over the square root of B squared minus A squared, which is 5 squared, which is 25 minus 9, which is equal to the tan inverse of the tan inverse of, this is 16, the square root of 16 is equal to 4, so that is 3/4. So this becomes the tan inverse of 3/4. Tan of, basically the tan inverse of 3/4, and the cot inverse of 3/2 would be, the cot inverse of 3/2 would be basically the tan inverse of 2/3. 2/3 based on this formula, right? Now, we need to add these together. So I'm going to say that, and I can use the formula, the tan inverse of x plus the tan inverse of y is equal to the tan inverse of x times y over 1 minus xy, 1 minus xy for x times y less than 1, which means that the tan inverse of 3/4 plus the tan inverse of 2/3 is the same thing as the tan inverse of 3/4 times 2/3, 3/4 times 2/3 over 1 minus 3/4 times 2/3. So that is equal to, what is this? This basically 3/4 times 2/3 is equal to, you can simplify these and you will get 1/2. So that the denominator would be 1/2. The denominator is going to be again 3 and 1 minus 1/2. 1 minus 1/2 is equal to 1/2. So that is the tan inverse of 1. So the numerator becomes 1/2, the denominator becomes 1 minus 1/2, which is equal to 1/2, and 1/2 over 1/2 is equal to 1. Which means that this is equal to the tan inverse of 1/2 over 1/2, which is equal to 1. So that is equal to the tan of the tan inverse of 1, which is equal to, now we need to make sure that basically this 1 is in the domain of the tan inverse function. So the domain of the tan inverse function is R, so we have no problem there, right? So that gives me a 1. That gives me a 1. That's the tan inverse of 2/3. It seems that I made a mistake over here. So I think up to this point we had no problem. The tan inverse of 3/4 plus tan inverse of 2/3. Oh, that is basically that is supposed to be that is not multiplication, that is x plus y. I'm sorry. Okay. So we need to calculate this again. So basically, based on this formula, I can say that the tan inverse of 3/4 plus the tan inverse of 2/3 is equal to the tan inverse of 3/4 plus 2/3 divided by 1 minus 3/4 times 2/3. Now to calculate this, you have basically 2, so 1 minus 1/2 is equal to, the whole thing becomes 1/2, and over here 3/4 plus 2/3 is equal to 12. 3, 9 plus 4 times 2 is equal to 8, 17 twelfths. So the numerator becomes 17 twelfths. So that is the same thing as the tan inverse of 17 twelfths over 1/2. And that you can write as the tan inverse of 17 twelfths over times 2. And then this becomes a 6, so 17 sixths. That is the tan inverse of 17 sixths. So I can write this as the tan of the tan inverse of 17 sixths. And that gives me 17 sixths as the answer. Okay. Now the next question that we have here is question number 18. Actually question number 19, which is get some more space here. So question number 19. Now question number 19 is the cos inverse of cos of 7 pi by 6. Cos of 7 pi by 6 is equal to 7 pi by 6. Choice A is 7 pi by 6. Choice B is 5 pi by 6. Choice C is pi by 3. And choice D is pi by 6. Okay, so basically to answer this question, you know that basically the cos inverse of cos of x is equal to x if x belongs to the domain of x, to the limited domain of x. The limited domain of x is the limited domain of the cos function. So we said that basically the cos inverse function was a function from -1, 1 to the range 0, pi. Okay, so that means that this is the limited domain of the cos function, meaning that we took the cos function, we limited the domain of the cos function to 0 to pi, and we limited the domain of the cos function to 0 to pi, and then based on that we got this domain for the cos inverse function. So that means that here x has to belong to the closed interval 0 to pi. The closed interval 0 to pi. Right? So what that means is that now 0 to pi, basically 7 pi by 6 is some angle which is basically pi by 6 plus, which is pi plus pi by 6, meaning that your angle is basically some angle over here. So if you go 7 pi by 6 is 30 degrees. So you have 1, 2, 3, and 4, 5, 6. So that is 6 pi by 6, which is equal to pi. And then if you go another pi by 6, you will get to this angle, which is 7 pi by 6, which is 180 plus 30, which is equal to 210 degrees, which is equal to 210 degrees. So as you can see, the the argument of the cos function is not in this range. It's not between 0 and pi. So you have to bring your angle back to basically some angle between 0 to pi. Now, in order to do that, we need to use the identities that we calculated before. And so, of course, you can, for example, use for example, pi by 2, for example. You can use, for example, pi by 2, or you can use pi. Now let's try one of these and see what happens. So, for example, if I say that if I used if I used pi by 2, you see, if I use pi by 2, the problem is that you know that basically when you use pi by 2, the trigonometric ratio changes. Meaning that if I go for pi by 2 minus x, or if I go for pi by 2 plus x, then the trigonometric ratio changes from cos to sine, or from sine to cos, or from something else to something else, which is not something that I want here. So I don't want to use, so I cannot use pi by 2, right? Now if I use pi, I would get, for example, the cos of 7 pi by 6. The cos of 7 pi by 6, I can write it as, so I know that the cos of, for example, x, if I want to write it as for example, pi minus some angle, would be basically the cos of pi, and minus x. Now, I do not really know what's going to happen here, so if I write the cos of pi minus x, so of course, since I have pi here, the trigonometric ratio is not going to change, it's going to remain a cos. And over here, I'm going to get some x over here, which is, that's not going to, that we know as well. But then the sign over here is important, right? So to basically to find the sign, we had a table that we developed earlier. And in this table, we said that, you see, in the case of pi minus x, first of all, in both of these two cases, the trigonometric ratio is not going to change. So you have no problem there. Now, in the case of the first one, pi minus x, only in the case of sine, the sign does not change. And in the second case, which is pi plus x, only in the case of tan, basically the sign is not going to change. Which means that basically in the case of the sine, so since we are talking about the cos, that means that there will be a sign change, because here we are saying only in the case of the sine there is no sign change. So there will be a sign change, and so I can write cos of pi minus x as negative cos x. And if I now take a look at the tables that we had before, we can see the same formula over here. So I have cos of basically pi minus x. I have cos of pi minus x is equal to negative cos x, as you can see. Okay. Now let's rewrite the angle using this identity and see what happens. So basically, based on this, so I can rewrite this as basically cos of x is equal to negative of cos of pi minus x, right? Now cos of x in this case is equal to cos of 7 pi by 6. Cos of 7 pi by 6. And that is equal to the negative of cos of pi minus 7 pi by 6. Now pi minus 7 pi by 6 is equal to pi minus 7 pi by 6 is equal to 6. So that is 6 pi minus 7 pi, which is equal to 6 pi minus 7 pi, which is equal to negative pi by 6, right? That is negative pi by 6. So that is equal to so let me see if I did this right. So 6 pi minus 7 pi, so negative pi by 6. Now I can write this as negative cos of negative pi by 6. Now you know that the negative cos of, basically cos of negative x, you know that cos of negative x is equal to cos of x, right? So I can write this as negative cos of pi by 6, right? So, and so negative cos of pi by 6. Now cos of pi by 6 is in this range, so I have no problem there. The only problem is that I have a negative sign there, right? I have a negative sign there, so we'll have to take care of that. Which means that I have to write basically the cos inverse of cos of 7 pi by 6 as basically as the cos inverse of negative cos of pi by 6, right? And now one thing that you need to pay attention to is that we said that basically the cos inverse of negative x is equal to pi minus cos inverse of x, right? So we said that the cos inverse of negative x is equal to pi minus cos inverse of x for x's belonging to the set negative 1, 1. So I can write this as the cos inverse of basically I could do that, meaning that I can write the cos inverse of pi, for example, minus cos inverse of for example pi by 6, right? That I can do. But now the problem is that this is not in the form that this is basically not in this form. Meaning that I wanted to get the expression in the form cos inverse of cos of x so that I could write it as x. So this is a problem. So we will have to use some other way in order to rewrite this expression, right? So probably we could use 2 pi, for example, instead of basically pi by 2 was not possible. Pi is giving us problems, so then we can use 2 pi probably. So let's try 2 pi and see if we can rewrite the expression. Okay, so now in order to rewrite the same angle in terms of 2 pi, so what we can do let's first try to find the angle, and then we will see about the rest. So I'm going to erase all of this. Now I want to write cos of 7 pi by 6 in terms of cos of 2 pi minus some angle, right? So I know that the cos of 2 pi minus x is equal to, well, first of all, there is no change in the trigonometric ratio, meaning that that's going to remain cos because I'm using 2 pi. And also I will have an x over here, and it's the sine. Basically we said that basically in the case of 2 pi only cos does not change. Only cos does not change, meaning that if you're dealing with cos, then cos does not change. And basically the mnemonic that we need to memorize here is AS for the first two cases, ST, and CX, ASSTCX. So that means that in the case of 2 pi, basically only cos does not change as far as the sine is concerned. That means that then the cos of 2 pi minus x is actually going to be equal to basically cos of x. Now, if I take a look at basically the formulas that we had basically, as you can see, the cos of 2 pi minus x, the cos of 2 pi minus x is equal to cos x. So that's the exact formula that we need. Now over here we have the cos of 7 pi by 6 is the cos of x. So I write basically the cos of 7 pi by 6, and that is equal to the cos of basically 2 pi, cos of 2 pi minus x. So 2 pi minus 7 pi by 6. Now 2 pi minus 7 pi by 6. Okay, so now cos of 7 pi, basically cos of 2 pi minus 7 pi by 6. So 2 pi minus 7 pi by 6 is equal to basically 6/12 pi minus 6 and basically minus 7 pi, which is equal to 5 pi by 6, right? So that is equal to the cos of 5 pi by 6. The cos of 5 pi by 6. And cos of 5 pi by 6 is basically some angle smaller than 180 degrees, and less than pi. So I can use it, and basically is in this domain. So I can use it basically over here, and so I can write this as the cos inverse of 5 pi by 6, cos of 5 pi by 6, which is equal to 5 pi by 6, which is equal to 5 pi by 6, which means that the answer is choice B. The answer is choice B. Now, question number 20. Question number 20 is question number 20 is the sine of pi by 3 minus sine inverse of negative 1/2. Negative 1/2 is equal to a 1/2 B 1/3, C 1/4, and D 1. So basically we have the sine of pi by 3 minus sine inverse of negative 1/2 is equal to 1/2, 1/3, 1/4, and 1. So basically we want to calculate the sine of pi by 3 minus sine inverse of negative 1/2. Negative 1/2. So let's first find out what is the sine inverse of negative 1/2. So the sine inverse of negative 1/2 is the same thing as so first of all, we know that basically the sine inverse of negative x is equal to negative sine inverse of x. Okay, for x basically belonging to the closed interval negative 1 to 1, which means that, so we know that the sine inverse of negative x is equal to negative sine inverse of x for x belonging to the closed interval negative 1 to 1, right? So basically then I can write the sine inverse of negative 1/2 as negative sine inverse of half, and then the negative sine inverse of half is basically you need to be looking for some angle. If you set this equal to, for example, some y, for example, if you set that basically the sine inverse of 1/2 is equal to y, then that means that 1/2 is the same thing as sine y. So you're looking for some angle whose sine is basically 1/2, which is pi by 6 30 degrees. So y is equal to pi by 6, because basically the sine of pi by 6 is actually equal to 1/2. But then pi by 6 has to be in the domain of the sine inverse function. The domain of the sine inverse function. So the domain of the sine inverse function is basically negative 1 to in the range of the sine inverse function, which goes from negative pi by 2 to pi by 2, right? And pi by 6 is actually in this range, so we have no problem there. And therefore I can write negative sine inverse of 1/2. I can write negative sine inverse of 1/2 as negative pi by 6. Negative pi by 6, right? So then this becomes the sine of pi by 3 minus negative pi by 6 minus negative pi by 6, and that is equal to the sine of basically pi by 3 plus pi by 6, pi by 3 plus pi by 6, and pi by 3 plus pi by 6 is equal to 60 plus 30, which is equal to 90 degrees, is pi by 2. You see, pi by 3 plus pi by 6 is equal to 6 here. 2 pi plus pi is equal to 3 pi by 6, which is equal to pi by 2. So that's the sine of pi by 2, and the sine of pi by 2 is equal to 1. The sine of pi by 2 is equal to 1. And that is basically your answer there. So the answer over here would be choice D. Question number 21. Question number 21 is tan inverse of square root of 3. Is the tan inverse of square root of 3 minus cot inverse of negative square root of 3, and that you want basically that is equal to choice A pi, choice B negative pi by 2, choice C is 0, and choice D is 2 square root of 3. Okay, so before we do this exercise, what I'm going to do is that, or let's do this one as well and finish the video here, because there is not much really to do here. So we have the tan inverse of square root of 3 minus cot inverse of negative square root of 3. So how would you basically, how would you calculate that? This is question 2. Tan inverse of, oh, that's actually number 21. That's actually number 21. And so basically the tan inverse of square root of 3, you can calculate it by basically the tan inverse function and the cot inverse functions. You know that basically the tan inverse function, you know that the tan inverse function is a function that goes from R to basically to the range negative pi by 2 to pi by 2, and the cot inverse function is a function that goes from, the domain is R, the range is 0 to pi, right? So which means that basically the input to your function can be anything, of course, there is no problem with that, but your outputs have to be basically, as you can see here, for the tan inverse function it has to be between negative pi by 2 and pi by 2, and for the cot inverse function it has to be between 0 and pi, right? Now if I want to calculate the tan inverse of basically square root of 3, what I need to do is that I need to basically, if I write this as y, then that means that basically basically tan of y is equal to square root of 3, and also y has to belong to this set, right? Not set, but interval negative pi by 2 to pi by 2. So that is one thing. Now, what is the angle for which the tan is square root of 3? So I think it is, I'm not really sure, but if you go for example, for the angle pi by 6, or basically 30 degrees, the angle pi by 6 or 30 degrees, you have the sine of basically pi by 6 is equal to 1 by 2. The cos of pi by 6 is equal to square root of 3 by 2. And so the tan of pi by 6 is equal to basically sine by cos 1 by 2 over square root of 3 by 2, which is 1 over square root of 3, which is not what we are looking for. So if you go for pi by 6, if you go for pi by 3 or 60 degrees, you know that the sine of basically pi by 3 is equal to sine of 60 degrees is equal to square root of 3 by 2, cos of pi by 3 is equal to 1 by 2, and so tan of basically pi by 3 is equal to square root of 3 by 2 divided by 1 by 2 is equal to square root of 3. So that means that the tan of pi by 3 is equal to square root of 3, which means that here y is equal to pi by 3. Is equal to pi by 3. And so what that means is that basically, and pi by 3 is some angle that belongs to this interval, and so then you can say that the tan inverse of pi by 3, the tan inverse of the square root of 3 is equal to pi by 3. Therefore, the tan inverse of square root of 3 is equal to pi by 3. That is the first part of this expression. The second part of this expression is cot inverse of negative square root of 3. Is the cot inverse of negative square root of 3. Now, we know that basically let me see if I can find this thing over here. So we said that the cot inverse of negative x is equal to pi minus cot inverse of x for all x belonging to R, right? So we said that basically the cot inverse of negative x is equal to pi minus cot inverse of x for all x belonging to R, which means that the cot inverse of basically negative square root of 3 is equal to pi minus cot inverse of square root of 3, and what that means is that now I can write the cot inverse of negative square root of 3 as pi minus cot inverse of square root of 3. Now, again, the cot function, to calculate the cot inverse of square root of 3, you know that the cot inverse function, the range of the function is is 0 to pi, right? So the range of the function is 0 to pi, which means that basically whatever you get as an evaluation of this expression, it has to be somewhere between 0 and pi. Now, if I want to calculate the cot inverse of the square root of 3, if I set that equal to y, that means that cot of y is equal to basically square root of 3, which implies that cos of y divided by sine of y is equal to square root of 3. Now, if I go for example, for pi by 6, what we have is that the sine is that is pi by 6 is 30 degrees. So you would have square root of 3 by 2 over 1 by 2, which would be square root of 3, right? So that means that you can say that basically the cos of pi by 6 over the sine of pi by 6 is equal to square root of 3, which means that basically y is equal to pi by 6. Y is equal to pi by 6, and it does basically the cot inverse function, it is somewhere between 0 and pi, so you have no problem there. So y is equal to pi by 6. Now what that means is that the What that means is that the cot inverse of basically the cot inverse of square root of 3 is equal to pi by 6. Is equal to pi by 6, which means that basically the cot inverse of negative square root of 3 is equal to pi minus the cot inverse of square root of 3. Cot inverse of square root of 3 is equal to pi by 6. What is pi minus pi by 6? That is 6 pi minus pi, which is equal to 5 pi by 6. Which is equal to 5 pi by 6. And therefore the cot inverse of negative square root of 3 is equal to 5 pi by 6. 5 pi by 6. Okay, so now the expression that we had here was the tan inverse of square root of 3 minus cot inverse of negative square root of 3. Was the tan inverse of square root of 3 minus the cot inverse of negative square root of 3. Negative square root of 3. And that is equal to tan inverse of square root of 3 we calculated here with that, which was pi by 3. That was pi by 3. And the cot inverse of negative square root of 3 was the cot inverse of negative square root of 3 was 5 pi by 6. 5 pi by 6, which is equal to 6 2 pi minus 5 pi, which is equal to basically negative 3 pi by 6, and negative 3 pi by 6, which is negative pi by 2. Negative pi by 2. So the option which is correct is basically this option here, and that's basically the answer, the right answer there. Okay, now what we need, basically we are done with this video. In the next video we will talk a little bit about the miscellaneous examples, and then we have some more exercises to do, and I'll see you in the next video. Thank you.